Um, we'll be offering these 8-week course on modeling transport phenomena of microparticles. Myself, Somnath Bhattacharyya, and my colleague, Professor G.P. Rajasekhar.
Hello.
We are from mathematics department, and for long we are doing research in these fluid dynamics, theoretical fluid dynamics, computational, viscous droplets. Professor Rajasekhar has worked on Stokes flow.
Yes.
And myself, we are working on electrohydrodynamics and all. So, basically our aim for this course is very can be stated in a very few words, is that because this nanotechnology and microfabrications and all becoming an emerging technology in these days.
Yes.
So, we felt that we should offer a course, something which deals with the microscale and nanoscale phenomena, transport
Yes.
phenomena, because in the regular coursework there is no such course which
applications,
right, where all the materials are put together in this kind of things. Now, what is transport phenomena? Transport phenomena basically here we will be doing as the either the mass transfer or heat transfer and fluid flow, momentum transfer. So, what we will be doing is basically that a mathematical modeling we will be doing, so which will be based on the conservation principles and other transport laws, physical laws which involves.
Okay.
So, this
right. We give specific examples and some simple problems we will be solving.
Yeah, to characterize the things. So, basically it the mathematical model involves a set of complicated nonlinear partial differential equations. So, we will be considering the simplified situations, as Professor Rajasekhar told, like Stokes law and rigid particles flow through porous media, transport process through porous medias.
Nice exact solutions using separation variables kind of.
Yeah. Now, microscale transports are basically low Reynolds number. That means these are can be approximated in a Stokes flow, that convective transport effects can be neglected in some situations, or turbulent is out of questions because of very low length scale, small length scale, because length scale is of micrometer or nanometer. Say micrometer means is 10 to 1 by 10 to the power 6 meter. So, nanometer is further lower, but because of this low length scale, there are several disadvantages. Disadvantages are because here the surface area becomes enormous compared to the volume, right. So, the surface phenomena like surface charge, then the surface say any kind of there will be a external forces or surface what is called the modulation things or obstruction. So, any kind of even few Armstrong is also plays a big role in development of the flow. So, this hydrophobicity plays a big role. So, that means we cannot consider always a hydrophilic surface, that is weighted surface, that no slip condition sometimes becomes questionable. Okay. So, another thing is that boundary conditions are very important, that is can have the absorbed charge density or surface tension, surface forces. These becomes are quite important in this condition. Another thing is that what we will be doing is we will first formulate the problems, that means the governing equations in mathematical form, and then a few examples through Stokes stream function will be introduced. And then we will go on the electrokinetic transport like electroosmosis of ionized fluid, then charged particle transport, that is electrophoresis, because this electric force is very important in microfluidics devices. Microfluidics devices means where it deals with a very tiny amount of sample, and which is portable and can be accurately measured several situations in a one kind of the lab on a chip form. Now, so in those cases the electrokinetic transport is very important.
Yes.
Now, as a prerequisite, if you are having a basic fluid dynamics course and a undergraduate numerical methods course and
Do well, yes.
right, partial differential equation course, that is good enough,
Yes.
because we will be starting from the very beginning.
Basics.
So, these basics will be sufficient.
Very much. Even
Right.
if somebody is not really done, but simultaneously there is a scope they can do
Right.
fluid mechanics and then understand this course. So, that flexibility is there. And as far as solution methodology is concerned, they have to use simple separation of variable techniques kind of in part of the problems. So, I am sure if somebody is not expertise, while going through this, they can work out the solution and then that they can do. Yeah.
Right.
So, that is my feeling.
So, the objectives of this course we have outlined. Professor Rajasekhar, can you say
Yeah,
a few
so
lines?
basically as Professor Somnath Bhattacharyya mentioned, so the objectives are so deriving the governing equations like mass transport and then momentum balance, etc. And then in simple cases exact solutions. Okay. So, very simple case exact solutions will be given, and then we move on to flow past rigid objects which are regular in shape, cylindrical, spherical,
Yeah.
and then also we discuss about viscous droplets which are without any surface activity and also surface activity due to some external gradient, and then we cover basic introduction of porous media and then fluid flow through porous pipes, etc., which has lot of applications in biology. Okay, in particular
Blood flow and all.
endothelial blood flow, etc. So, these are the things. So, that is the objective of the course. Okay. And then who can attend? That is the immediate
That is,
question.
no, you missed a little bit.
Oh, yes, please,
like
please, yeah.
this electrically driven flow in
Oh, yes, that
micro and nano scales and
Yes.
migration of charged particles.
Okay.
And also another important thing which we should mention is that we will introduce numerical techniques to
Oh, yes.
solve the transport phenomena. Show an introduction to the numerical techniques to handle the transport phenomena, because in many cases we will have come across nonlinear set of
Analytically
partial
not
differential,
possible to
which
solve.
is not analytically possible.
Correct.
So, and the course will be supplemented with lot of assignments and
Yes.
simpler problem related to transport phenomena situation.
Yes.
So, some illustration and yeah,
Who can attend? That is
Right,
an important
yeah,
thing people
yeah.
will be interested in knowing. So, basically it is aiming for B.Tech, M.Tech and PhD students from various disciplines like chemical, mechanical, aerospace, biotech, material science, metallurgy, and MSc PhD students from mathematics, physics and any applied background, and of course faculty members, engineers and researchers from industry, academia. So, they
particularly bio
related,
metal,
yeah.
medical technology. Nowadays, this is very
Important
emerging
area.
ideas.
Okay. So,
Now-
some illustrations to just create some excitement. So, you can see, so these this is a viscous droplets, of course spherical in some ambient flow, and this is a charged colloid in a porous media. Okay. So, then these are some microorganisms. So, lot of applications of microparticles can be simulated okay, to mimic the swimming microorganisms, and these are flow inside porous tubes or porous lining as an approximation to flow inside a glycocalyx.
Are you considering as a soft particle the microorganisms or is a porous particle?
No, these are rigid with
Rigid.
some cilia coating.
Okay,
So,
sure.
that the cilia beating drives the flow.
Okay,
So,
very
that is
good.
the main thing. And in porous pipes, etc., we are considering for the time in this course we are considering porous media as a rigid porous matrix. We are not considering deformable and then tissue. But once they understand this mechanism, I am sure they will be able to read and then understand the deformation.
Right.
Yeah.
So, in addition, these electrokinetic transport phenomena.
Yeah, a lot of applications are there for the.
Now, electrokinetic has because of this portability and also this electric field, you can regulate it very smoothly compared to a pressure driven flow and all.
Yes.
So, that is why this is becoming day by day, it is a very emerging area.
Yes.
So, this is some examples the how the electroosmotic flow looks like. You see, this is a kind of
Very
flat profile. So, plug like situations, and this is a streamline.
Yeah.
First a rigid colloids, and this is the ion distribution,
Yes.
how the deformations are occurring. So, these are the few illustrations, and we can say some references.
We are giving, so that you get to know and refer sometimes. And we are sure at the end of this course you will feel that you are ready to attempt some research problems. I am sure you get such an excitement. I think they should be able to attempt end of this course some research paper they can read and understand.
Right, the way we have prepared our lectures, that all the equations and all will be deriving.
Yes.
So, it is not that we are referring to some other, only this, if you have that prerequisite, what is partial differential equation, the basic knowledge of fluid dynamics,
you can enjoy better.
Little bit of numerical, that is good enough to have this course. With that, we thanks.
Yeah, so looking forward for you to be on this course. Thank you.
Thanks.